Hello, everyone, and welcome to my presentation. My name is Kyle Connolly. I'm a mechanical engineer who has been with Boeing for the past 10 years. Today, I will be discussing a proposal for the construction of material testing lab at the recently opened facility in Messi, Arizona. Composite materials are the future for aircraft, and Boeing is quite aware of this. That is why recently the Advanced Composite Fabrication Center in Messi, Arizona was opened in September 2022. Under the current program, this facility manufactures composite aircraft components, but ships those components out to perform testing elsewhere. The parts are shipped all over across the country to undergo various different testing, depending on what that part will be used for in the aircraft. This is a costly and time-consuming process. It is time-consuming because you have to wait for the shipping time and then for the facility to be able to test the item, get the data, analyze that to determine the results, and report that back to the design team. And it is costly based purely off the shipping cost that you're spending to deliver the part to the other facilities. This program makes sense for larger components that require more elaborate and expensive large testing equipment. However, for smaller components, this can easily be prevented by testing the material here at the Advanced Composite Fabrication Center. This brings us to the proposed program. Currently, there's an unoccupied office that has been vacant for several months. This office can be turned into a material testing laboratory with minimum renovations to the space and with the purchase of several testing machines and additional equipment. This is a picture of the layout of the unoccupied office. The testing that would be done at this new laboratory would be tension and compression, impact, hardness, heat treatment, and the microstructure of the components could be analyzed from this lab. This is a new picture of the proposed layout that the lab will have. In addition to the equipment and the testing machines, there would also need to be some slight renovations. A few electrical outlets would need to be added, and additionally, you would have to add some plumbing to create the sink that would be needed to safely operate the furnace. This will allow for the testing of small components right after manufacturing. And if a test results in a material not meeting the design requirements, then this information can quickly be relayed to the design team so adjustments can be made immediately and the correct part can undergo manufacturing. For the current budget, it is between 243,000 to 486,000 per year, and that's if you consider that for the smaller components, it is either 5 pounds to 10 pounds, and there's 3,000 made per year. And if you take those considerations along with the $1.35 shipping cost per pound, you get the 243,000 to 486,000. Now, how this stacks up to the proposed program, the first year is almost 200,000, and that is because you have to take into effect the equipment cost and the renovations, which is 22,545. But every subsequent year after the first year of the program, it would be 177,000, and that is for the cost of the materials engineer and the two material testing technicians that would have to be hired to be able to effectively run this lab. And this is a pie chart that shows the percentage cost of construction and just to create the lab. So you have 72% for the test machines and then additional equipment for those machines, 16%, and then renovations would be 12%. And then in terms of savings, if you compare it to the 5 pound savings, the initial year would be 18%, every after year would be 27, and then the 10 pounds would be 59, and then every after year would be 63. So at best, you're looking at a savings of 18%, but considering the facility fluctuates between the weight of the parts that are produced, you're probably going to be more around the 30 to 40% savings. In conclusion, this would allow instant testing of the small composite components that are manufactured at this facility, and it would save the company money by eliminating shipping costs, and by allowing instant feedback on the test results, it would allow the design team to be more productive. This will allow the facility to reduce the time needed to achieve the goal of manufacturing the aircraft of the future. I would like to thank all of you for your time, and at this moment, I will gladly answer any questions you may have.